Welcome back. Carrying on with our discussion of Chapter 7. We learned a new reaction that was very useful. We could do a backside attack on a carbon with a leaving group and do this SN2 type reaction to create a new bond here. Why couldn't we just do that with the alcohol? Why does this not happen? This is not going to work. The question is why? Looks like the same one as the one below it, right? And the reason is you would make this leaving group very poor leaving group. It's too unstable. There's no reason to generate it. We have a reaction that doesn't happen. That's why there's a big X through it. So you get rid of this. This is just a waste of time to even think about it. Now, if your nucleophile was an acetylide, like we have been using, that's the only carbon nucleophile we know of so far. It's not only is it a good nucleophile, it's a good nu, also strong base. You want to know how I know it's strong? pKb 14 minus 25. Negative number for pKb means strong base. So you try to do this reaction up here, you get a reaction. It's not the reaction you want. This C minus takes the H off the alcohol and you get a carbon with an O minus and acetylene. You took something that was very valuable and made it into something that nowhere near as valuable. It's not a nucleophile anymore. It's gone. You got to take its H off if you want a nucleophile again. So there's somebody that might have called and said you're fired. So we can make alcohols into alkyl bromides to get this reaction to happen. And we learned a good way to do it was PBr3. And that would let us do the synthesis step we want to do. Okay, that's one loose end from SN2. We have one small topic that we need to discuss for test 3, and then we'll actually do in our final segment today, we'll do a beginning of our test 3 review, because this topic will not take long. Okay. We need to know another way of making alkynes, and this one's from alkenes. And what you can do is learn about this new reaction. Elimination bimolecular. We're going to study it in depth in chapter 9. We need a strong base. Must be strong. Plus we need a carbon with a leaving group. Our favorite leaving group's chlorine, bromine, iodine today. And you can have other stuff on there. The important stuff, though, I'll put in a different color. The important stuff is the leaving group, which I got rid of so I can put back in a different color. And you also need an H on this adjacent carbon. Don't we have a word for adjacent carbon? Oh yeah, that word is vicinal carbon. Just trying to get that to be a carbon there. Good. That's the vicinal carbon to the carbon with the leaving group. In chapter 9, you're going to learn that's called a beta carbon, and the carbon with the leaving group is called alpha. But right now, if you have a strong base and you add this, that's not the math symbol, that's chemistry, that's heat. And what happens is you get this bimolecular elimination called E2, bimolecular elimination. And the base grabs an H from an adjacent position to the alkene, the carbon with a leaving group. The sigma becomes pi. That reminds me a little of tautomerization. That sigma becoming pi, and the leaving group does what leaving groups do. It leaves. Cl minus, very stable. What did we make? We made a pi bond. Okay, well, we can make a pi bond from an alkyl halide. Now, what would happen if my molecule had a halogen on adjacent positions? Could I not do the same thing twice? What I'm beating around the bush to get you to say is, if I have two halogens, I can do two of these eliminations. So how can I make that molecule up there into this molecule here? And that's a reaction that will be on your test. I'll put like a Cl here and a Cl here, wedge and a dash. We're supposed to know how to do that. That's a pretty bad looking Cl. A little better. Oh yeah, let's just add chlorine. Cl2. 6.1 C in your textbook. Halogenation. And now I can treat this with strong base and heat. This new reaction I just learned. So strong base and heat. I don't know. How about H minus and heat? We can do the reaction we just learned once to make a double bond there. Still have an H over here. Do it again. H minus mole number 2. And heat. Mole number 2. And you get the same result. We'll even do the mechanism for both. Ooh. It's going to be linear. You've read about my pet peeve, right? Yeah, if I see zigzag triple bonds, I'm not a happy guy. I like to see linear here. On tests, don't worry. I will not give you trouble. Unless it's a question about geometry, I'm not going to give you a hard time about how you draw your triple bonds. That's what I'm trying to say. Then we use the mechanism above. The H minus can grab this H. The sigma becomes a pi, and the leaving group does what leaving groups do. It leaves and gives us this alkene here. And then you have another vicinal carbon to this chlorine. And the same story, encore une fois, one more time, gives you a triple bond where you used to have a double. You started with the double up here, halogenated both ends, did elimination E2 number 1 right here, E2 number 1, and E2 number 2. And this is yet another way of making alkynes. It's useful. You will not be using this method on your retrosynthesis question. You've got to follow the protocol we did in the retrosynthesis question. This is just another way to do it. And that is the last topic for test 3.
Doctor, quick
Yes.
question. With the initial reactant at the top of the page, there was no halogen. Do we just like add it? If
We had to put the halogens on our alkene. So this is step 1, right here, step 1. And then step 2 starts here. and you would just use an excess of H minus. You need more than 2 moles of H minus for 1 mole of this, right? Because the first mole does the first elimination, and then the second mole's right here. It does the second elimination. So this would be step 1, halogenate it. So you have a leaving group on both sides, and then do the E2 twice to make 2 new pi bonds.
Oh, yes, I understand. I'm talking about the reaction at the top of the page. You
This
said
one?
you have something like this in the exam. You see on the left side, there is no chlorine. I'm saying, do we just
Right.
add it if we
Yeah.
had that?
Yeah, the answer to this question mark is this
Oh,
is part of the answer,
okay.
and this is the second. So I think what would be helpful for everybody is if I took this. Oh boy. Give me a second. We'll get this right. We'll make it nice. Overall answer on the bottom here. Didn't get any extra stuff. That's good. Move it down here, get rid of our question mark and fill it in with an answer. And here goes. Step 1, halogenate it. Chlorine's good, bromine's good. Iodine works too, I'll give it to you. But 1 was halogenate it. We used chlorine, let's use it again. And 2, you just say like KHXS and heat. And that's the answer. Box it up, make it a nice box. Make it a nice blue box. And that's our answer. And that's the end of this segment. So we're going to come back for review. And I'll show you what the review is going to look like, because your first question in part 4 will be similar to this one. And this has got a lot of points. There's more than 25 points here. I don't know if yours will be that big, but the idea will be just as important on your first part 4 question. So I stole this from Spring 17 Test 3, first question of part 4, and we'll pick it up after the break and finish today with that. See you then.